HNC hyperbolic functions. So this question involves catenary and pylons. So you may have seen before a parabola. So if you throw a ball through space and we ignore air resistance, because gravity is the only force acting on it, the pathway of the ball will follow this. This is the function. This is the algebra that describes that pathway. So x being how far that way, y how far vertically, okay? So that is the function, that's the parabola. So it's very easy to confuse that with this. So this here is a catenary. And I think Galileo noticed a difference between these two, which I find amazing given slow motion cameras and things like that in those days. It's quite a very sort of detailed observation. If you look at Wikipedia and derivations of catenary, then eventually end up with this, okay? So this here models basically how the y value changes with x, okay? Now because this occurs quite a lot, the maths people, instead of using that, they call it the hyperbolic cosine function. Okay? So this occurs if you dangle a cable between pylons, it will follow that shape. Spider's web will follow that shape. And a very clever thing I saw on a YouTube video, better than this one, was in a church, to get the strongest arches, they had two pillars there that previously built, imagine they're church pillars. You dangle a chain, and then probably get some sort of template, reverse that, and then you do masonry based on that. And you basically get your strongest arch that way. Pretty clever stuff, eh? That's the catenary. Okay, that's my introduction. The actual question then is we have two pylons. Let's step that a little bit. I'll move this back a bit. That's a mistake there. We've got two pylons, so we'll make these pylons 140 metres apart. Okay? Question is how high do these pylons have to be suspended from? So symmetry states that actually these will be the same height. I put my origin here, so that's 0, 0. That being y direction, this being the negative x direction, positive x direction, okay? So therefore we can write down that that is just minus 70, and that's plus 70. Okay, that ordinate there. So now comes in your hyperbolic cosine function. So with a calculator, there's two ways you can do this with a calculator really. One way is to put in, first point there, minus 70 here. And the second way is to, that's your formula. The value of x is minus 70 in this case. Minus 70 there, plus 70. So type these into the calculator, I get an answer. So, by use of the hyperbolic cosine button here, and this fraction button, I'm able to get this answer here, which is 40.987. Meters. That being a millimetre. Okay, so that's pretty accurate. Now in engineering, there is no answer book. So if you can do things by a different approach, and you get the same answer, that is increasing the chances of your answer being correct. Okay. We've got, it's 1 decimal point, sorry, 2 decimal points, 40.99. 40.99. So what I've done then is I've used a website called Desmos. I've typed in the function here. Okay, and that gives me my nice red pathway there, my nice continuity there. The pylons are simulated with these lines here. So those lines are x equals minus 70 here, and x equals plus 70 there. So you can see that when I click on here, I'm getting that same value. Okay, that's given 3 decimal places, 40.97 in there, yeah? This sort of demonstrates that what I did there was correct. Okay, so that's it.